Hi fellows, this is Chemaddcts again to the solution. Welcome back to another video tutorial. Well fellows, now we're gonna solve this question. Okay. So previously we have done an experiment and we have calculated the rate of the equation. So if you have missed the previous tutorial, so don't need to worry. I will put the link to that tutorial at the end of this video. Okay. So let's proceed. So in here the question says the rate constant K was calculated at different temperatures. So suggest a practical method for keeping the temperature constant. Okay. So well, in order to keep the temperature constant, we should always use water bath or ice bath to make the temperature constant. Why? That's because this will so that temperature is evenly distributed. Okay. So in order to keep temperature constant, we need to make temperature evenly distributed throughout the solution. So for that we need to perform the reaction in the water bath or ice bath. So the answer to the first question is performing performing reaction in the water bath or ice bath. Both will do, water bath or ice bath. Okay, so that's the answer to this question. Okay, water bath or ice bath, so anyone will do. You may write water bath or ice bath, these are optional. Okay, these two are optional. Well, so I hope that you have understood this question. So let us proceed to the next question. Okay, so in this question the table shows the measurements of the rate constant K at different temperatures. Some of the corresponding values for reciprocal of temperature and ln K are shown. Okay. So here at first they have asked us to complete the table uh, calculating the missing values. Okay. So here this 1 by T means the reciprocal of this temperature. Okay. So T is temperature, here T is temperature, and this 1 by T is the reciprocal of this temperature. Okay, corresponding temperature. And this K is rate constant, where ln K is the ln of rate constant. Okay, so 1 by T, let me write it here. Okay, so 1 by T is 1 by temperature. Okay, and here ln K means log to the base T K, which is where the K is rate constant. Okay, so in here let us calculate the values. So if we calculate this missing value over here, okay, so here 1 by T means this one 1 by 320. So if we calculate 1 by 320, right, yeah, 320, so we will get 3.13 3.13 into 10 to the power minus 3. Okay. So the value for this one should be 3.13 into 10 to the power minus 3. Okay. So let us now calculate the value, the corresponding value for ln K. Okay. Here the value for K is 8.65 into 10 to the power minus 4. So let us calculate the value for ln K. Okay. So here K is equals to 8.65 to 10 to the power minus 4. Okay, so now let us calculate ln K. So ln K means log base E 8.65 into 10 to the power minus 4. Okay. So if we calculate, we will get something like minus 7.1. So the value for this one should be minus 7.1. This value should be minus 7.1. Let me write this here. Minus 7.1. Yeah, fine. So we have completed this two part. Now let us go to the third part of this question. So let us see what does the question say. So the question asked plot a graph of ln k on the vertical axis against 1 by t on the horizontal axis. Okay. Calculate the gradient of your graph and use this to calculate the activation energy EA. Remember to include units with your answer, which should be given to three single figures. Here the Arrhenius equation is given. The Arrhenius equation can be expressed as this ln k is equals to minus EA by R into 1 by T plus a constant. Here where gas constant is equals to R is equals to this. Okay. So this is given. So in here we can see that the total mark for this question is 7 for 3. For question 3 the total mark is 7 for this particular question. Okay. So let us at first break the things into smaller parts before answering the question. So the first part of this question is this plot a graph of ln k on the vertical axis of this. Okay. So for this the total mark would be 3. For the first part of this question is the mark for the first part is 3. Okay, and for this part the total mark is 4. So in total we will have 7 mark for this question. For the first part the mark is 3, and for the second part the mark is 4, and the total mark for this question is 7. Okay, so at first let us uh, answer the first part. Okay, so we're gonna deal with this question part by part. Okay, so let's do it. So before plotting the graph, let us do a little bit of analysis of this data. Let us do a let us analyze this data given. So if we analyze, so here it says ln k on vertical axis, which is y, and 1 by t on the horizontal axis, which is x. So 1 by t should be in x-axis and ln k would be on y-axis. Fine, totally fine. So as you can see that here the values are extremely small. Okay, the values are extremely small, so we need to deal with the scaling. Okay, so it would be difficult to scale the graph. It would be a little bit tricky to scale the graph. So we will examine that later on. So in here the we are okay with the values of ln k. Okay, so now let us research this Arrhenius equation given. So why ln k should be y-axis and why 1 by t should be on the horizontal axis. So let us justify this thing by this equation. Since this Arrhenius equation is identical to the straight line equation, okay, so here let us compare this equation with the straight line equation. Okay, so for the straight line equation the equation should stand for y is equals to mx plus c. So if we compare this with the equation of straight line, we will get something like this: y is equals to mx plus c. So where y is equals to ln k, uh, where m is equals to minus ea by r, and where x should be 1 by t. Since this is identical to the equation of straight line, we can write like this, and we can plot a graph of 1 by t on x-axis and ln k on y-axis. Okay, this is how we're gonna do. So now Now uh, let us move on to the plotting. Okay. So let us move on to the plotting section. At first, let us plot this graph. So if we plot this graph, so we're gonna get something like this. Okay. So we're gonna get something like this. So let me make it shorter. So more shorter, more shorter. Mhm. Okay. Yeah, fine. So as we can see that on this is the uh, one. So as we can see that this is the x-axis, okay, and this is the y-axis. Since this is horizontal and this is vertical. So as we can see that since since all the values of y is negative here, so we didn't keep a space, or we have shifted the graph at the top. Okay, so we have plot the x-axis on the top in here, leaving no space for a positive y-axis. So that's why we have plotted we have labeled this x-axis over here on the top, and we have labeled this y-axis on the bottom, since all the negative since all the value of y-axis is negative. Okay, so in the y-axis we can see that this is ln k, and x-axis we can see that this is 1 by t, or per Kelvin. So here is something that we need to know, that so if we do the scaling correctly, we will get 1 mark. Okay, so 1 mark is for appropriate scaling, and second mark is for labeling both axes correctly, since uh, labeling both axes correctly, just like this is 1 by t per Kelvin. So we need to mention the name of the axis. Here in this case, this x-axis is 1 by t and the unit is per Kelvin. So we also need to mention the name of the axis as well as the unit for the axis. Okay, so in this case the name of the axis is 1 by t and the unit is per Kelvin, which is k to the power minus 1, just like that. Okay, so on the y-axis, this is ln k, and this shouldn't have any unit. Okay. So okay, so this is ln k, fine. Now the last mark is for points correctly plotted and straight line is drawn. So we should uh, plot the points correctly. As we can see that this student has plotted the points correctly. Okay, so this is appropriate plotting over here, and drawing the base fitted line. So as we can see that this student has plotted correctly, more accurately, and this straight line is precise. This is not bolted, or the straight line is not overwritten. So this is the most accurate uh, straight line. Okay, I believe. Okay, so what? So now let us see how do we should do the scaling thing. Okay. So at first let us look at the scaling at x-axis. Okay. So since this 10 to the power minus 3 is common in all here, okay, on the x-axis. Just see, since here um, so since here this 10 to the power minus 3 thing is common in all data on the x-axis, so we can ignore it while plotting. Okay, so we need to mention in the graph, but we may ignore it while plotting, while we are doing the calculation. Okay, so let us see how we should ignore, okay, and plot the graph. So in here, since this whole thing is 10 to the power minus 3 over here, so we may calculate this as 3.20, this as 3.40, and this as 3.60 as a whole, since 10 to the power minus 3 is common in all points. So that's why, since the scaling is also linear over here, so in here we have taken 20, yeah, 20 box as 3.20, so here this should be 3.10. Okay, and in here, so in here 20 box represents 20 units, 0.20 units. Okay, so in here this is 0.10. Okay, since 3 is common, so we will ignore that. This is 0.10, this is 0.20, this should be 0.30, 3.30. Okay, just like that. This is 3.40, this is 3.50, just like that. We're gonna plot like this. Okay, so we have taken 10 box as 3.10. There are 10 boxes 3.20, 3.30, just like that. Here the scaling is linear. As long as the scaling is linear, then your graph should be correct. Okay, just like that. Here the scaling is linear. Here the gap is 10 boxes, 10 small boxes. Here the gap is 10 small boxes. Here the gap is 10 small boxes, just like that. Okay, the length between each box is equal if you have calculated. Okay, so let us move on to the y-axis. So in here, these values are pretty big, as we can see. This is 2, 3, 4, 5, 6, 7. So we may uh, calculate like this. 10 box would represent 1 unit. Here 10 box represents 1 unit. So 1, 1, 2, 2, 3, 4, 5. This is 1, then 2, then 3, 4, 5. So we didn't consider 1 in here. We just break the scaling over here, and we have introduced 2. So from we will calculate from 2. Okay, so 2, 3, 4, 4, 4, 5, 6, negative 5, negative 6, like just like that. We're gonna go like that. Okay. So in here the gap between these two is 1 unit. Okay, so 10 box represents 1 unit, so 1 box would represent 0.1 unit. Okay, so let us write it here. So on x-axis, okay, so 1, not here, 10 box represents 0.1. Okay, we just ignoring 3 thing and 10 to the power minus 3, since 3 is common in all number. Here 3 is common, 3, 3. I hope that you have understood. Just like that. Here 1, so 0.1 divided by 10 will give us 0.01, like on x-axis. And let us move on to the y-axis. Let us see at y-axis. On y-axis, So on y-axis, in here 10 box represents 1 unit. So one box would represent 1 by 10, which is 0.1. Okay. So each small box represents 0.1 unit on y-axis. On y-axis, each box represents 0.1 unit, and on x-axis, each box represents 0.01 unit. Given that we have ignored these 3 and 10 to the power minus 3 for calculation purposes. So we are doing this for sketching. Okay. So this is not real for actual value. Okay. Since the actual value is really small, so we're gonna deal with we're gonna deal like this. Okay. To make things easier. So this is it. So now let us plot this graph. So in here, let me see. So in here, the first point is 3.57 into 10 to the power minus 3 on the x-axis. So the first point should be 3.57. So the first point should be 3.57. So as we can see that since on x-axis this is uh, the smallest point represents 0.01, so the 3.57 should be here, somewhere here. This is 3.55, this is 3.55. Okay. Since this is 3.55, okay, in the middle, since this is 3.56 and this is 3.50, so 3.57 should be here. Okay, here. So the point should be here. So this point is 3.57 depending upon minus 3. So we have calculated from the x-axis. We have just taken the point here. This is the 3.57, and we have gone straight downward and find the point over here. Okay, so it is here. So we have found the x-axis. Now let us find the y-axis. So on the y-axis it says 12.5. So here this is minus 12 and this is minus 13. So on the middle this should be minus 12.5. So this is how we're gonna calculate minus 12.5. So we have find one point. Then another point is just as before. Now we're gonna calculate just like that. Okay. So this is this is on the y-axis is 3.45 into 10 to the power minus 3. On the y-axis this is minus 11. Okay. So in here we can see that this is 11 minus 11. Here we will take the point here, and let us move on to the y-axis. So in y-axis the point is minus 11. Okay, so we have point here, point it here, and on the x-axis let us move on to the x-axis and find the corresponding value, which is which is 3.45. Okay, so let us see. So 3.45 is here. So this is 3.40 and this is 3.50. So this should be 3.45. So yeah, here it is 3.45. Alright, this is 3.45. Okay, so same as before, we're gonna plot another thing from the data given. So this is another point is 3.33. Same as before, we will go just like that. 3.33 point, sorry, 3.33 into 10 to the power minus 3 and minus 9.6. Okay, So this is minus 9.6. The point is over here, as we can see. Okay, and 3.33 is somewhere over here. This is 3.30. We will move uh, 3 boxes right and down to here. So here it is. Okay, this is how we're gonna do. So let us move on to the next one, that is 3.23 into 10 to the power minus 3, and another thing is minus 8.3. So in here this is minus 8.3, here we have calculated, and this is 3.23. So let us find the 3.23. So this is 3.20 over here. So we're gonna move 3 boxes right and all the way down until we find minus 8.3. Okay, so that is how we're gonna find the points on the graph. Okay, so it's really easy, just like simple graph plotting. It is just easy. Just we're gonna ignore the small values, just like uh, 10 to the power minus 3. 10 to the power minus 3 is common over here, so we're gonna just ignore this thing, and we're gonna ignore this thing, so everything else would be the same as before, just like that. So it would be easier for us to draw this uh, complicated graph. Okay, so now let us plot 3.13 into 10 to the power minus 3 minus 7.1. So as we can see, this is minus 7.1 and 3.13. Just as before, we're gonna look at where is 3.10 here, 3.10 is here, and we will move uh, 3 boxes right, and we're gonna go all the way down until we find minus 7.1. So that is how we're gonna plot this graph. So I hope that you have understood the plotting. So now let us move on to the another part of this question. So if you still don't understand this solution, please let me know in the comment section, and I'm always there to help you out. Okay, okay, so now let us move on to the next part. So in the next part, they have asked us to calculate the gradient of the graph and use this to calculate the activation energy. Okay, so they have asked us to, at first they have asked us to calculate the gradient of the graph, and then they have asked us to calculate the activation energy. So if we want to break this down, so here we have two parts. So in the first part, we're gonna calculate the gradient of graph, okay, that we have made, and use this to calculate the activation energy. Oh, before going to this topic, so let me tell you one thing, that this graph, after plotting, you should draw a perfect straight line meeting all these points. Okay, so here we can see that all these points have met, and if they doesn't meet, then you need to draw a base fitted line, so that these points should be closer to each other. Okay, closer to the straight line. So that is how we're gonna plot base fitted line. So if the points are not on the straight line, that's fine, we're gonna draw the base fitted line, so that the points are really close to the straight line, and one must be out. Suppose this is this point must be out, since this is an analogous reading. Okay, so that's how we're gonna do. Okay, so now getting back to the question. So at first, let us calculate the gradient, the gradient of the graph that we have obtained just before. So here we need to see one thing. For calculating the gradient, we need to take the greatest triangle as possible. Okay, so we might take this triangle, okay, or this triangle. It's up to you. In this here we will consider this triangle. Okay, this smaller triangle. Since we all know these points, this is 3.13 minus 10 to the power minus 3 and minus 7.1, and this point is 3.57 into 10 to the power minus 3 minus 12.5. So the gradient would be just like this, y1 minus y2 divided by x1 divided minus x2. It's simple arithmetic thing. Okay, so here let us take y1. This is minus 7.1 minus, here this is minus 12.5. Okay, this is 3.13 into 10 to the power what minus 3, then minus 3.57 into 10 to the power minus 3. Okay, we have taken the corresponding value. Okay, sorry for my handwriting. This is minus 7.1 minus minus 12.5, and this is 3.13 into 10 to the power minus 3 minus 3.57 minus 7.1 minus minus 12.5, difference of this thing. Okay, divided by 3.13 into 10 to the power minus 3 minus 3.57 into 10 to the power minus 3. Okay, so that's how we're gonna find the gradient. So if we calculate this thing will come as minus 12273. Okay, so this is how we're gonna do. So here let us do it again here. So if we calculate the gradient here, if we calculate the gradient, we need to show the proceeding here. So there, for the sake of understanding, I have just calculated there, but you must calculate here in the space given here. Okay, so you won't uh, get any mark. So you won't get any mark if you calculate there. Okay, just for rough work we have calculated here, but the main working you should, for the main working you should do here. Okay, in the space given. You understand? I know you understand. So this is what. So what values we have taken? See, minus 7.1, 3.13. Alright. Yeah. So minus 7.1 minus minus 12.5. Okay. So this is 3.13 into 10 to the power minus 3 minus 3.57. This is 5 into 10 to the power minus 3. Okay. So if we calculate, we will get something like this. But minus 12273. Okay, so for this calculation, this should be per Kelvin, whatever. So uh, for the gradient, you will get 1 mark. Okay, so for calculating the gradient, you will gain 1 mark. Okay, so in here, since we have calculated the gradient, this is the gradient. Okay, so gradient is minus 12273. So since we have calculated the gradient, we have achieved 2 marks. Okay, so now let us calculate the activation energy. Since we know that from the Arrhenius equation that minus EA by R is M, if we can compare the Arrhenius equation with the straight line, so gradient is equivalent to minus EA by R. Okay, so we know the gradient minus 12273 is equals to minus EA by R. Okay, so let us make the E subject, minus E is equals to minus 12273 into, here the value for gas constant is 8.31. Okay, so we will get something like mm, mm, let me write it here. All right, so we will get minus EA is equals to minus 101989. Okay, we will get something like this. Then if we cancel out this negative sign over here, if we multiply both sides by minus 1, we will get EA is equals to 101989. So let us round this up, so we will get 10200 joule. So for calculating this whole thing, we have achieved 2 marks. So 2 plus 2 is equals to 4. 4 marks for this part, 4 marks for this part, and 3 marks for the for plotting. Okay, 4 marks for calculation and 3 marks for plotting the graph. Okay, so here is one thing that you need to know, that the definition for activation energy is it is the energy required. So if we recall the definition of activation energy, we will get that it is the energy required for the reaction to occur. Okay, it is the minimum energy required. So since it is the minimum energy required, so it must be positive. Okay, so it must be positive. So in order to uh, EA to be positive, in order for EA to be positive, so here the gradient must be negative. Okay, so here you should obtain the negative gradient in order for EA to be negative. Sorry, EA to be positive. In order for EA to be positive, the gradient should be negative. By the phase of the graph, you may say that this should be a negative gradient since the line is downward. Okay, this is the straight line is facing downward, so the gradient should be negative. So for your calculation, the gradient must come negative, then your EA should be positive. Okay, so that is how we gonna do. Okay, so fellas, I know that it's been a lengthy video, so since we have discussed in details, and I really appreciate that you have still stick to the end, and I really love to see that. I love to hear that my solution is helping you a lot for the exam, since the exam is really close. So I'm I'm hoping I'm hoping the best for you. I'm hoping you the best, all the best for your exam. Okay. So fellas, if you have any question regarding this topic, or if you have any question regarding this uh, solution, please let me know in the comment section. Okay, so I'm always there to help you out. So that's it for today. I don't want to make it further longer, so signing out. Best of luck for your exam. Stay awesome, stay cool, stay stay cool. Okay. So peace with chemistry. Bye guys. Bye fellas.